Hello, my name is Robert Smith, and I'm with New River Community College. And today we are looking at how to name coordination compounds in accordance with their IUPAC. So it's kind of the same way you would with any other species. You want to name the cation and then the anion. And thankfully, when we write these out, they're written out in such a way that it goes cation and then anion. Of course, you can always just solve for it based on what you see. And each species is listed in alphabetical order, so it's very important that you know what the shorthand term is for all the ligands involved. So that should be readily available to you. And so for this first one, what we want to do is, first you want to do, just like we did in our last video, find the oxidative state on ruthenium. So we have 2 Cl minuses, and so this whole big thing has a 2+ charge. Now water is a 0, has no charge to it, and neither does ammonia. So that means that our ruthenium is a 2+. So we'll just make a note of that over here. Okay, so now we can name our compound. So again, you want to start in alphabetical order. Now, ammonias are known as amines when you're looking at naming of compounds. And waters are referred to as aqua when you're naming coordination compounds. So we're going to start with the we're going to start with the amines, and then the aquas, and then the metal. And after we do the metal, we'll add the anion at the end. So in this case, we want to make sure we use the proper prefix for each of the ligands. So this one would be pentamine. And yes, there are 2 A's. So that's 5 amines. Monoaqua, 1 water. Ruthenium, 2. And I'm going to put this, and then chloride. So that would be the full name of this coordination compound: pentaamine monoaqua ruthenium 2 chloride. Let's do another one. So this one, we start off with 3 nitrates. A nitrate has a -1 charge. So then this coordination compound, CrNH3, 6, would have to have a 3+ charge. And again, ammonia has no charge associated with it, so chromium is going to be a 3+. So okay, so now we just have to name the compound again: cation, then anion. And we don't have to worry about alphabetical order because there's only one type of ligand. You name the ligand and then the metal. So in this case, it would be hexaamine, chromium 3, nitrate. Okay, and that should be a lowercase n. All right, let's go to the next one. Just 2 more. This one we don't have to worry about the charge so much because we know that carbon monoxide has no charge associated with it. So iron is going to have an oxidative state of 0. So we're just going to name it right off the bat. So we have penta for 5. It's 5 carbon monoxides, carbonyl, carbonyl. So pentacarbonyl, iron, 0. Now, sometimes instead of iron, just as a classical thing, classical nomenclature that is used sometimes in coordination chemistry, coordination compounds, you might use ferrate. Zero, and that's okay too. The iron zero is just as okay as ferrate zero. But you may not be accustomed to noting the zero when putting the charge on a metal. In the past, you've only ever seen iron 2, iron 3, and so forth. But yes, you can have a zero, and you do want to denote the zero in the coordination chemistry. This last one, we have 4 potassiums, and each of them is lending a plus charge. So that means that our overall charge is going to be is going to be a -4 on this one. And we can break this down and say we have 6 cyanides. They're each lending a -1. And so that means that the overall is -6, but we want to get to -4. So iron has to be a 2+. So that now we can name this coordination compound. Again, you start with the cation, so potassium. And remember that when you're naming metals, you don't use the prefix to denote the number. That number is going to be implied by the charge of the various species that we list out next. And then so potassium, and then there are 6 cyanides, so hexacyano, and then iron 3. So let's call it ferrate. I'm sorry, iron 2, ferrate 2. And you can use iron 2 if you'd prefer. It might be a little easier, but classically they use things like ferrate to denote that stuff. Just like lead would be plumbate and so forth.